Hello and welcome to a Maths with Harry lesson. In this video, we're going to be having a look at fractional powers. In a previous video, we had a look at negative powers and we had a look at the index laws. Today, we're going to focus strictly on fractional powers. So a fractional power is when we've got a fraction in the power. It also sometimes might refer to it as being a rational power. And rational just means we can express the number as a fraction. So let's say we have a look at some rules. Now I'm just going to highlight that. Here is the rule. For when you've got a fractional power, let's say we had a to the 1 over m. What do we do with that? So again, this a is my base, and this is my power, and this is a fraction. It's a rational number because it can be expressed as a fraction. What I've got here is 1 over m. What I can do with that is I can actually simplify that and get rid of any powers. And to do that, what I do is I take, and I'm just going to write this as a straight line, I take the mth root of a. So the bottom number here is my root that I take. Okay, so if I've got a to the 1 over m, that is the same as the nth root of a. So whatever that number is, if m is 2, then we take the square root of a. If m is 3, we take the cube root of a. If m is 10, we take the 10th root of a, whatever a may be. Alright, so that's the first index law. Now what happens though is if we've not got 1 on the top here? Well, what we do, and I'll just box that rule off there. That's the first rule. If we have a to the n over m, well, we know what the m does. We take the mth, just write that as a straight line, we take the mth root of a. But what happens to the n? Well, we can write n over m as n times 1 over m. So the 1 over m bit is what gives us the mth root, and then the n, that's still in the power. So all we do is then take the nth, take that to the n power, to the power of n. Okay, so that's what we do with fractional powers. Now, just want to very quickly note that that is actually the same thing as also having the power underneath the square root. And we'll have a look at an example of this. If I had that, that's actually the same thing. So, you know, we can do the power first, then take the square root or the mth root, whatever n may be. Or we can do the root first and then take the power. So let's have a quick example of that. Let's say we wanted to, first of all, have a look at 2 to the 4 over 2. Okay, and in fact, I'm not going to have that as a 2, I'm going to have that as a 4. So what we're going to do is we are going to write that as the square root of 4, but then it still works because our bottom number is a 2. We need to introduce a 2 here, but we never write the 2 because it's just square root, so that can disappear. And then raise that to the power of 4. So the square root of 4 is 2, so we know we can simplify that, and then we can still have the brackets to the power of 4. Now remember, that's 2 times 2 times 2 times 2, which is 16. Now, we could have done, like I said here, this version. So what we could have said is, and I'll do example 2 here, 4 to the power of 4 over 2 will be equal to, and I can do the square root of 4 to the power of 4. So 4 times 4 times 4 times 4, that is 4 to the power of 4. 4 times 4 is 16, times 4 is 64, times 4 again is, now this is testing me, 4 times 4 is 16, times 4 is 64, and then 64 times 4, we could do it like this if you wanted to. 4 times 4 is 16, and then 6 times 4 is 24, plus the 1, 256. Sometimes we also need to do that multiplication. So 256 is what 4 to the 4 is. So then what we could do is, well, we can simplify what 4 to the 4 is. So that is 256, and then I'm going to have to use a calculator here. If we use a calculator, we can take the square root of 256, and voila, that gives us 16. And we could have actually got that from there because it works both ways. So those are just a few examples, okay? So we can do that exactly the same. All right, let's box that one off because that's also another law, and those really are the only other laws. We covered the 2 other rules, as I call them, in the previous video, and I'm just going to rub that out so that I have got a bit more room. Let's have a look at some examples. Alright, here are 4 examples. We'll just do 4. You can press pause and have a go if you want to have a go at them, and then you can press play whenever you're ready. Now let's work through the answers. So hopefully you had a go at them. I'm just going to move them down a little bit so that we've got enough room. So for part A, well, we can't really simplify anything with part A because we've got a fractional power here and a fractional power. We don't know what x is, so we can't do anything in terms of fractional powers. But what we can do, if you have seen my index law video, is we can simplify and we can merge everything together and simplify into one term. And to do that, we will just add the powers. So that will give us x to the 1, because a half plus a half is 1, and then x to the 1 is just x. So not really much involved with fractional powers there, apart from the powers are fractions. But we can't use any of these rules because we don't know what x is. Okay, now just one thing while we're on this example, anything to the power of a half is the same as square rooting, because if you think about what this rule says, x to the half is the same as the second root of x, which is just the square root of x. So now really, whenever you see square root, think about it maybe as a fraction, or whenever you see a fraction, think about it as the square root when the fraction is a half. All right, let's have a look at B. So for B, what we needed to do was just calculate this. Now, you could possibly just put this in your calculator. It doesn't really matter. But in an exam, let's say you didn't have a calculator, then you would need to know how to do this. Of course, the x is involved here, so you would have to know the value of x to put it in your calculator. But it's still quite useful anyway to be able to manipulate these. So the first thing I'm going to do is I'm going to get rid of this square root. And, well, it's actually a cube root in this case. We've got a 3. I'm going to get rid of the root. And to do that, what I'm going to do is I'm going to write it as 125x to the power 6, all to the power of a third. Because remember, when we've got this case 1 over m, it's the mth root of a. Here we've got the third root, or the cube root of 125x to the 6. So I'm going to write it 1 over m. Our m is 3, so write it to the power of a third. And then what I'm going to do is I'm going to use one of the index laws to kind of distribute that power over. So that's going to give me, and that should be in blue, so I'll write it from blue. Now on, so 125 to the third, because I can distribute that power to the number, and then multiplied by x to the 6, all to the power of a third. And then all I can do is just work that out. Now, 125 to the power of a third is of course the same, and now I can write that like that. the cube root of 125. I actually don't have to write it like that. I could just go straight and think, right, well, a third, when I've got that as a power, is the cube root. But I'll write it like that so that you can see. And then I'm multiplying that by x squared, because I can simplify by multiplying those powers. And 6 times a third is the same as 6 divided by 3, which is x squared. Okay, so what is the cube root of 125? Well, that's 5, because 5 times 5 is 25, times by 5 again is 125. So that is going to give me 5, and then multiplied by x squared is just the same as writing 5x squared. Okay, so there's my x, and there's 5x squared, and I'm just looking whether to see those are correct. And of course, those are correct. Perfect. Okay, let's have a look at C and D. So all we need to do here is just compute what these are. There's no algebra involved. I could simply put these into my calculator without thinking what the value of x is, because we have got no x. So we could check this if you like, and we'll do it on our calculator first. 49 to the power of 3 over 2 gives me 343. Let's keep that in mind. That's what we need to get to. So here we're dealing with the second rule, because we've not got 1 on the top of the fraction, or the top of the fraction is the numerator. We've not got 1. So what I need to do is I need to write this as the second root of 49 all to the power 3. So to do that, well, I'm going to take the square root of 49, which will give me 7, and I'm going to raise that to the power of 3. And then when I do that, 7 times 7 is 49, times 3, I'm going to guess, is 343. And that is our final answer. Here we've got a negative, so I'm going to write that as 1 over 25 to the 3 over 2. And then what I'm going to do is I'm going to take the square root of 25, which is 5, raise that to the power of 3, and straight away I can get 1 over 125. And that is your final answer.